During this video, we will be solving two problems. The first one is to solve the integral of x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. To solve, first we will factor the denominator. Now our integral is in a form where we can use partial fraction decomposition, and by doing so, we will get the integral of a over x plus b over 2x minus 1 plus c over x plus 2. Every polynomial in the denominator is of first degree, so our numerator degree must be 0, which is why we have a, b, and c. Now we want to multiply both sides by the greatest common denominator. We're going to leave the left side alone and apply the distributive property. Now we're going to distribute the a, b, and c. Next, we're going to get all of our x squareds together, x's together, and constants together. Because the left side equals the right side, all coefficients must be equal, so we can set up systems of equations. For our x squared term, we will get that 1 equals 2a plus b plus 2c. The 1 comes from the 1 in front of the x squared. For our x term, we will get that 2 equals 3a plus 2b minus c. The 2, again, comes from the 2 in front of the x. For our constant, we will get that -1 equals -2a. From these equations, we can see that a is the easiest to solve for. So, by using -1 equals -2a, we get that a equals 1/2. Now we want to plug in 1/2 everywhere we see an a in our x squared and x term equations. By using algebra, we will simplify the two equations. For our x squared term, we get 0 equals b plus 2c. For our x term, we get that 1 equals 4b minus 2c. Now, we can do elimination with the two equations. By adding the two equations together, we get that 1 equals 5b plus 0c. And by doing algebra, we can see that b equals 1/5. Now that we have our a and b, we can plug both 1/2 for a and 1/5 for b into our x squared term equation, and by using algebra, we can solve for c. Now that we have a, b, and c, we can plug these numbers into our partial fraction decomposition that we solved for earlier. Now we can solve the integral. First, we're going to want to solve the integral of 1/2 over x, and we will see that this is a relatively easy integral to solve, and it's just 1/2 the natural log of x. However, to do 1/5 over 2x minus 1 is a lot more complicated, so I'm going to solve it over to the side. First, we will use u substitution, and our u will be 2x minus 1, and our dx will be du over 2. We'll take out the 1/5 constant, and by multiplying by 1/2, we will get 1/10 the integral of du over u, which is a relatively easy integral, and it's just 1/10 the natural log of u, which is 2x minus 1. Now that we have that answer, we can plug it into our final answer. Next, we only have the integral of negative 1/10 over x plus 2 to solve, and like the first one, this is relatively easy, and it's just the negative 1/10 the natural log of x plus 2. But because our integral has open bounds, it needs a plus c. And this is our final answer to the integral of x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. Now, our final question that needs to be answered is a true or false question. That asks if the integral of 2x squared minus x plus 4 over x cubed plus 4x, if we can split the integral into a over x plus b over x squared plus 4. And we will get that this is false because x squared plus 4 is a second degree polynomial, so the numerator must be a first degree polynomial, and b is a 0 degree polynomial. If we wanted to solve the correct answer for it, it would be the integral of a over x plus bx plus c over x squared plus 4.